Well, good afternoon to you. This is Dr. Randall again, and I'm here to do the second installment in my series of examples on developing Streamlit interfaces to work with langchain based AI agents. This is March 29th, 2026, and I'm hoping you have a nice last weekend of March this year. But let me find it. The As I told you last week, I have a Streamlit recipes repository on GitHub that you're free to download and use and adapt for yourself. If you recall last week, I did a very simple example, and I'm showing it to you here. It's running in, I've launched it from PyCharm, and it's running in my web browser, Chrome. And this is pretty rudimentary application. It's basically just a starting point. What's rudimentary about it is it's not really an AI agent because, for one, it doesn't have any ability to perform autonomous actions. It doesn't have any tools hooked into it. It's really just a GUI that lets you ask questions of a large language model. And here it's using GPT OSS. It's deployed locally and served up by my Ollama application. And it also has no memory. So if I go here and ask, say, something like, my favorite food is Detroit style pizza. Not really sure if that's true, but got to think of something to say. And then say, what drinks go well with my favorite food? Okay. So it responded to my first one that, oh, that's a solid choice. Detroit style pizza is a bit of culinary cult favorite, blah, 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 blah. But now that I ask another question, sure thing. To give you best pairings, it would help to know a bit more about your favorite food. I just told it my favorite food, and it doesn't remember because it's not programmed to remember. All it is an LLM. It's static. It knows what it was trained on, and it's not keeping track of the conversation. So how useful is that? Well, it's mainly useful as a starting point, an example, to show you what you can do with the UI. Now, I started with this, and I built upon it. And this week, I want to show you an Ollama agent chat. And it's also, since I'm running them at the same time, it came up in dark mode, which was interesting. I didn't choose dark mode. I guess that it was the first time I ever ran two at the same time, and it just came up in dark mode. So maybe it just does that on its own. But this time, it does have a memory. And some other things I added to it. I took out all of the widgets to show all of the various parameters of the particular model chosen, because you can always go back to the first one if you want to see that. And I added let you pick the stream mode. There's two different stream modes. Well, there are actually three, but there are two main ones. The streaming values, you can stream one token as a time as you receive it, and it'll display it across the page as each word is received. Messages, on the other hand, it delivers the information in full messages, and so there might be a little bit more lag and less visual feedback as you're waiting for answers to come back. And I've also added a widget for defining a system prompt, and you can like I have it default to, you are a helpful assistant whenever the user asks you questions about current events. Use your web search tools to obtain the most up-to-date information. And I'll get to the web search tools in a minute here. But you can see that this now has a memory. And I'll show you also how I added that. My favorite food is Detroit style pizza. Okay, I'll give it time to actually respond before I input my next question. And it also responded, that's a classic choice. Detroit style pizza is known for its thick, buttery, square crust and blah, 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 blah. And now I'll ask, what is a good drink? I'll be a good boy and say, what is a good non-alcoholic drink? That pairs with my favorite food. And it's thinking. A few non-alcoholic drinks that go well with Detroit style pizza. It remembered. Okay. So it remembered. And another thing, now let me switch to demonstrate the next concept. Let me actually switch to a notebook in PyCharm. Okay. Let me find it first of all. Okay, the application I'm going over today is the Ollama chat agent. And this, the code for the application I was just showing you in the browser is Ollama agent chat main.py. And I've also created a notebook, Ollama agent chat, to experiment with a few things. And you can go through that to see just the langchain related items, and it may be less confusing than having all of that mixed together with the Streamlit UI components. But let me run this. The first thing I'm doing is I'm loading up the .env file using load.env. And this next cell is initializing the Ollama LLM to the chat Ollama and defining the system prompt. And then it's creating the agent. Now you'll notice here that in this create agent line, it's not defining any tools. It's saying, okay, the system prompt is, you are a helpful assistant whenever the user asks you questions about current events. Use your web search tools to obtain the most up-to-date information. But I'm not giving it any web search tools. So what's it going to be able to tell me? So now I'm going to ask it, who is the current mayor of New York City? Current mayor of New York City, it doesn't say anything because this particular model was actually completed and trained before the election. So let me see what it says if I ask it this question. I'll just copy and paste this. say, how up to date is your knowledge base? And I'll just print out the response. By the way, when you call invoke on an agent returned by create agent, what you get is a response object, and in its messages component, it has a list of various messages. And the first message will always be a human message, and it will contain the question that you submitted. The last message will be an AI message, and its content will contain the answer. And there may be one or more messages in between the human message and the AI message, but in this case, it's probably just the human message and the AI message, because the agent is too simple. It doesn't have any tools to find, so it's not going to have like a tool message or another AI message sandwiched in between the first and the last. So when this statement is going to get the final answer from that final AI message, because by indexing -1, I'm getting the last element in that list. So saying my training data goes up to June 2024. So anything after June 2024, it's not going to know. It's not going to have real-time information. Okay. Well, just as an example of how to define tools and hook them into an agent, this next cell, first of all, it imports a decorator from langchain's tools called tool, and on the function that you want to use as a tool, or any function that you want to use as a tool, you just decorate it with the decorator at tool. And you have to also remember to put in an explanatory docstring, because it actually pulls that out as metadata so that the agent can select when calling that tool is appropriate. Another thing you can do is you can say, give it a different name. I could say raise to third, and then I could say description, and I could give it a much more elaborate description. But in this case, the default ones are good enough. The name of the function is pretty explanatory, to the third power, and the docstring is, it says what it does. Okay, so that's enough in general. So now I create a new agent, and this time I provide it a list of the tools that it can use. And I gave it a different system prompt, because I'm telling it, you are a master of arithmetic. Use your tools whenever the user asks you to raise a number to the third power, to help it along a little. Now, when I ask what is 8.5 to the third power, it says 8.5 to the third power is 614.125. It actually called to the third power to compute that. Okay, but in our case, we don't. In my Streamlit UI, I want it to go out and search the web. How do I do that? Well, Tavily, now you need to install langchain Tavily with UV or pip to have access to this. But then you can import Tavily search, and this has been decorated with the appropriate metadata so it can be hooked in to AI agents. And so I create an instance of this Tavily search tool, and then I provide that to the create agent. Now, when I ask it who is the current mayor of New York City, now it's going to take a little longer because it's having to call an external API. The current mayor of New York City is Zoran Mamdani. He was sworn in as the 112th mayor on January 1st, 2026. So it actually called out, did a web search, and found that information. And to see what it actually gave in the response messages, I have this print out in this cell. And the results were, first of all, the human message that I spoke of earlier, who is the current mayor of New York City. But the second message is an AI message. The content of that message is blank. But what it does have is it has a section called tool calls. And the agent determined that it needed to call the Tavili search tool with the query current mayor of New York City. And so it called that tool. In response, a tool message came back with the content, and then the agent parsed all that out, came back with a lot of information. Oh, it actually called tool, did 2 tool calls. Not always determinate, but then the final message is the AI message where it has parsed out from those tool calls the actual answer to the question you asked in the first place. And then it gives that in the content field of that last message. Okay. So going back to the browser, that's what this this was doing. Okay. And I've also given this interface a system prompt. So the system prompt can be really important. If you go and look at other applications online, you will find some very, very elaborate and detailed prompts. And you rarely find prompts that are this small. But prompt can make a huge amount of difference. Like I can say, okay, you are a crusty, old, retired pirate, and you hate answering questions. Okay, hit Control Enter. Okay, now I will clear this. Okay. What's a fun thing to do in Boston in the spring? Ah, ye landlubber, pull up a chair and let me spin you a yarn in the fire city of Boston. Okay, I do a terrible accent, but anyway, you get the idea. Yes, it took on that persona. And okay, let's see. Let's see. What is the best material for a good peg leg? So I wonder if it's doing a Tavili search. I'm sorry, but I can't help with that. I would think you'd be an expert. Okay, it answered something, but you can have a lot of fun with that. I won't be ridiculous and try to read that like a crusty old pirate myself. But anyway, you get the idea. Now, one thing to keep in mind is not all models support tools. Now, GPT OSS does. One I know does not. I've tried the Gemma 327B here. And let me give it a different prompt. You helpfully perform web searches to answer user questions. And this is the first time I've tried this, so I'm not sure what'll happen. Okay, but I know that this particular model does not support tool calls, so if it tries to call the Tavili search tool, it'll fail. I'm hoping that it just doesn't try. Say, who is the current governor of Virginia? Oh, yep. It says, does not support tools. Okay. Well, my hopes were dashed, but at least it put out a error message that I could figure out exactly what was wrong. But anyway, Gemma 327B does not support tools. Now, of course, this one, the Nomic Embed Text latest, it doesn't support chat either. So keep that in mind. This is actually for creating vector embeddings, so that won't work. Try Qwen 3. See what happens there. Who is the current governor of Virginia? Well, it hasn't crashed yet, so maybe it's using the tool. Probably is using the tool if it's taking this long. Oh, Abigail Spanberger, it used the tool. So yes, Qwen 3.8b, 8 billion parameters, uses tools. And it's also a much smaller one than the GPT OSS with 20 billion parameters. So if your hardware doesn't support anything that big, then at least you know you can play around with this. So now I will go through the code very quickly. I would recommend that you just go through it on your own and but again, it's doing all of the imports first of all, doing the set page config, which needs to be the first thing it does pretty much after the imports. And generally one of the first things you do after that is to set up all of the items in your session state that you're going to continually reference. So I'll load up the environment, set the model, and set the base URL. Also set a first system prompt, and as I said before, this is set up to have memory. And I maintain the ID of the current thread, a chat thread, in the thread ID item in session state. And this function, annotated with cache resource, is for obtaining the agent. So anytime the model name, the base URL never does change, but you can change the model, and you can change the system prompt. It's going to, the next time you call get agent, it's going to create a new agent and update that and return it. New chat is called whenever you click the button underneath the title that clears the messages. It just zeroes out the messages in session state and also increments the thread ID in the session state. And whenever you do, you enter something in one of your chat input widgets, it calls agent chat. And depending upon the stream mode, if it's values, it's one kind of syntax. You're calling agent stream with a stream mode of values, and it returns individual steps. And if you stream your stream mode is messages, it returns a tuple containing a token and metadata, and the actual word that's returned is in the token content, and that's what it yields right here. So anyway, you can go through all of this and figure these things out and play with it. It's actually about 25 lines shorter than the previous program that I demonstrated last week. And Langchain has done a very good job of developing a very powerful library where you can get a lot of fancy things done in a very few number of lines of code. So I hope you enjoyed this, and look out for another video probably next weekend. And happy sailing until then.